Okay, so we're going to do a little bit of solving inequalities, and I hope it's not going to get sort of too hard. We're going to try and keep this on the easier end of things. You might not think so later, but I promise. So I'm trying to keep away the tricky questions. And it's just basically like solving, just solving before, which is why we're going to start with a few questions to remind us of how to solve. Now, remember what solve means? It means, let's write this up here. Find the value of the letter. And we mean the variable. This, the letter in an equation is the variable. It can have a value. Our job is to try and find that value when we say solve. So your job is to try and get it on its own. So it then says x equals whatever it equals. Okay, so pause the video. Please have a go at all 5 of these, even if you're not sure. Just have a crack at it, see what you can get, and then unpause when you've done all 5 and written them down with working out and the question. Okay. Okay, we've unpaused. I'm just going to get rid of that little question mark there because I don't want that. So if we've got 6x and that equals 54, well, I don't want 6 of them, I only want 1. And the way that we remove that is by doing the opposite of what it is. And this is 6 lots of x, 6 times x. So I divide by 6. And if you've got 6 lots of something and you divide it into 6, you end up with just 1 of them, okay? 54 divided by 6 is 9. So x has a value of 9, and that makes sense, doesn't it? Because 6x, 6 lots of 9, is 54. Perfect. This one, again, I want to get y on its own, and it's y plus 11 equals 32. So that's something plus 11 is 32. So what I'm going to do is take away the 11. Yeah, and I'm going to do it from both sides of my equal sign. I should have said that over here as well. On all of these, you do the same thing to both sides of the equal sign to keep it balanced, right? And keep it, as it says, equal. So something plus 11 equals 32. It says take away 11, because 11 take away 11 just cancels out. It leaves y on its own. And 32 take away 11 is, I don't know why I'm thinking about this. That's slightly weird. Why am I thinking? 21. Oh dear. It must be late in the afternoon. Okay, now x over 5. Remember what maths this means? This means divide. Something divided by 5 is 4. So if I want to get rid of that divide, cancel it out, I've got to do the opposite. I've got to times by 5 to get x back on its own. But we've got to do it. If we've times this side by 5 to get rid of it, I need to times this side by 5 as well to keep the whole thing balanced. X has a value of 20, and again that works, doesn't it? 20 divided by 5 is 4. Now these are 2-step equations. All those were 1 step because they only take 1 step. These take 2 steps. And the trick is that I generally say the number that's touching the letter, whether it be divide or times, deal with that last. Deal with the other bit first, this plus 8. And as always, just like all of these, we're doing the inverse. We're doing the opposite. So if it's plus 8, I'm going to take away 8, because 8 take away 8 is nothing. It will leave 2x on its own. But of course, we need to keep things balanced. So if I'm going to take away 8 from one side, I need to do it from the other as well. So 2x equals 10. And then, the dog's very excited about that. Yes, I know, Murphy. I know you know what to do. You do this. You've got a number touching a letter like that. It means times, so we do divide. So if 2x is 10, 1x must be 5. That makes sense, doesn't it? Don't want 2 lots of something, we just want the 1. Okay, over here again, we'll deal with the number touching the letter last. Deal with the other bit first and just do the opposite of what it is, right? So don't even need to think about it. If you're thinking, I don't know what to do, don't think. Just look at it. What is it? Minus 3. We'll do the opposite. Add 3. And that just has the effect of cancelling it out and making it disappear. 3 take away 3 is nothing, right? But obviously, whatever you do to one side, just do it to the other. So this side, just add 3 to it. Just like you've been doing since, I don't know. When do you start adding and taking away? Is that year 1? Year 2? Yeah, I don't know. Okay, and we've got 4x. I don't want 4, so we'll divide it by 4. To get 1x, and 32 divided by 4 is 8. Okay, so you might want to look up that if you're struggling with that a little bit, if it's been a while since you've done it, but otherwise I'm going to move on, and there will be other examples as we go. Now what we're going to do here is solve an inequality, and remember, an inequality has a range of answers, not just one fixed solution. So before, I might have had an answer like x equals 2 or x equals 5, but now I'm going to have a range of answers. I'm not going to have these sort of things. I'm going to have something like x is less than 5, so literally any number less than 5, or x is greater than or equal to 2, so that would be 2, or anything above 2 would be an answer to it. And so here's a first one. So we got 5x is greater than 35. Now my hint here, first of all, just pretend that it's an equals. Just do exactly what you would do if there was an equals there, except we're going to leave that sign in there. Now how can I go, oh, actually let's get rid of that, it's a bit stupid. So we're going to do exactly what we did before, except we've got a different sign in the middle. Now 5x, let's say pretend it equals 35. Well, in that case, I would have divided by 5. Got a number touching a letter, divide by it. 5x divided by 5 is just x. But 35 divided by 5 is 7. So the answer to this is x is less than 7. Literally anything less than 7 will make this inequality work. So it's no different to what you've done before, except you've got a different sign in the middle. Still keep it balanced. Still doing the opposite. No different at all. And I want to put it on a number line as well. I've got a blank number line here, so I'm going to choose wherever I think 7 is. Let's say 7 is there. I might put 0 in as a reference. And x is bigger than 7. Remember, when it's bigger than or less than, we have an open circle. And we point in the direction of the numbers we want. We want x to be bigger than 7. So we point to anything that would be bigger than 7. That's to the right. Certainly not to the left, because 0 is not bigger than 7. Like that. Okay, let's try another one. So x take away 8 is less than or equal to 3. Again, I just want x on its own. So what I'm going to do is do the opposite. I'm going to add 8. But remember, do it to both sides of your inequality. Now, 8 take away 8 is nothing. It just leaves x on its own. It makes that 8 disappear. 3 plus 8 is 11. So x is less than or equal to 11. So again, I don't have a single answer here. I have a whole range of answers. Let's put 11 on here somewhere on my blank number line, and let's put 0 as a reference. Now it's less than or equal to 11. Remember, less than or equal to or greater than or equal to, filled in circle. It includes that 11, and it's less than that, so we point to all the numbers that are less than that. There we go, less than or equal to 11. Right, try those. So you've got, I think, 3 here, and we'll do them on blank number lines as well, please. And pause the video, unpause when you are done. Okay, we've unpaused, and there's my 3 blank number lines. Now, for some reason, my cat wants to join in. I'm not really sure why, but I'll move the drink out of the way just in case he wants to come late. He probably wants to just check you're doing it right. Now, 7x is greater than 28, but I don't want 7 of them. I only want 1 of them, so I'm going to split it into 7 equal pieces. I'm going to divide it by that number. Divide by 7. And 28 divided by 7 is 4. And just put the same sign in. See, not rocket science. We're literally just doing what's there. So x is bigger than 4. That's the answer. And on my number line, I just put a reference for 4, maybe a reference where 0 might be, and then put the sign in. Now it's greater than. There's no equals to, so we have an open circle. Because x is bigger than 4, I point to the numbers bigger than 4. Not to the left, because they're all smaller than 4. It's to the right. This one up here, okay, take away 12 to get rid of the 12, and do it to both sides of your inequality. Keep the same sign, just take away 12. So 12 take away 12 is nothing. Well, that's what I wanted, wasn't it? Get y on its own. 30 take away 12 is 18. So y is greater than or equal to 18. Again, empty number line, so just put a reference for the number, maybe a reference for 0, and it's greater than or equal to 18, and because it's equal to as well, I put a filled in circle, and I point to all the numbers that are bigger than 18, which is to the right. And lastly, 6x is less than 30. Well, I don't want 6 of these x's, pesky little x's, I just want 1 of them. So we divide it by that number touching the letter. We divide it by 6. So 6x divided by 6 is just 1x. 30 divided by 6 is 5. And use the same sign. X is less than 5. Now, if it's confusing, go back and watch it again. Maybe watch me on half speed. I'm talking like this. And then that'll be more entertaining. X is less than 5. So let's put a little reference for where 5 is. Put a little reference for 0. Now it's less than. There's no equals there, so it's just an open circle. My inequality doesn't actually include 5, just everything smaller than 5. And because it's smaller than 5, I point to the side that is smaller. To the left. Yeah, okay. Right, come on. Try some more. So we're going to solve this one. So this, again, it's very similar to the ones we've just done, except it's a two-step equation, which means I've got 2 steps to solve it. But again, you just treat it like a normal equation. Instead of an equal sign, we've got a greater than sign. That doesn't matter, you just write a greater than sign. So deal with the number touching the letter last. So take away 3. You know, again, don't think about it, just do it. Just look at it. It's a plus 3. I'm going to take away 3, because 3 take away 3 is nothing. Just do the opposite. 4x is greater than 27 take away 3 is 24. Again, you've been doing take away since I'm informed that it's a reception. So, you know, just do it. Just do the opposite there. And then we're going to divide by that number touching the letter. So divide by 4. X is greater than 6. Because 24 divided by 4 is 6. So x is literally anything bigger than 6. So on my little number line, I'm going to do where the 6 is. Again, I'm just going to reference where 0 is. It's greater than 6, so that it's not filled in. There's no equals. And point to the numbers that are bigger than 6, which is to the right. Da-da-da! There we go. Again, here we go. So 7x, take away 5 is less than or equal to 9. So take away 5. Deal with the number touching the letter last. So let's do plus 5 to both sides. Keep it all balanced. Let's look at the right-hand side first this time. 9 plus 5 is 14. 5 take away 5 is nothing. So 7x is on its own. And that's why we did it, right? Because we wanted x on it. Oh, 7x on its own. And then divide by that number touching the letter. We don't want 7x. I just want 1. So cut it into 7 pieces. 1x must be 2. That makes sense, doesn't it? Because 7 times 2 is 14. Yeah. So x has the value of 2 or anything smaller. So there's my number line. Reference the number you're trying to put on, which is the 2. Put wherever, 0 might be. And it's less than or equal to 2. Because it's equal to as well, we do a filled in circle because it does include 2. And because it's less than, I point to all the numbers that are less than 2 to the left. So same thing as before, except it's a 2-step equation. Again, 3 for you to have a look at. And then we'll move on to something else. Okay, deal with the number touching the letter last. Pause and unpause when you're done. Well, you've unpaused and I've drawn my little lines there, so let's go. 3x take away 6 is greater than 27. Okay, well, let's add 6 to both sides of the inequality, because 6 take away 6 is nothing. So 3x is greater than 24 plus 6 is 33. Now I don't want 3x's. You can probably guess what 1x must be worth just from looking at it. Let's do it officially. Let's divide it by the 3. 33 divided by 3 is 11. So x is bigger than 11. Literally, I mean, it's just, again, not rocket science, just x is literally anything bigger than 11. Now to show that on my number line, mark where the number is, 11. You might want to put where 0 is. Put any other numbers you like, but those, 11 is the important one. Because it's only bigger than 11, not actually equal to 11, I do an open circle and point to the numbers that are bigger than 11 to the right. This one, plus 9, so I take away 9. 9 take away 9 is nothing, so 2y is left on its own. 15 take away 9 is 6. Well, if 2 lots of something is 6, well, let's divide by that 2 to find that 1 lot must be 3. So y is bigger than or equal to 3. So either 3 or above. There's 3, Let's put that as 0 there. Because it's greater than or equal to, the equal to is the important thing there, do a filled in circle and then point to all the numbers that are bigger than 3, because that's what it says. Y is bigger than or equal to 3. Just make sure that's clear, that's a 3. Not a 5, it's a 3. And it does look like a 5, doesn't it? I promise you it's a 3. Down here, let's add 4 to both sides of my inequality. So 6x is less than 24. And then let's divide by that number touching the letter. Divide by 6 to get 4 is less than... Sorry, x is less than 4 is what I was trying to say there. Yeah, so we added 4 to both sides and then divided both sides by 6. Okay, on the number line, again, mark where 4 is, mark where 0 might be. It's less than 4, there's no equals, so it's an open circle. And we point to all the numbers less than 4. Now, your line is going to be better than that, isn't it? I certainly hope it is, because that's rubbish. So much so I'm going to redraw it. Again, you should be using a ruler. I can't use a ruler because it's on the screen, which I find very frustrating. There we go, less than 4. So let's look at something slightly different, but you do the same thing, right? So like, you're getting easy maths today because we're not actually really mixing it up that much at all. It's all the same thing, just looks a bit different. It's still the same technique. So look at this, we've got one of those two-sided inequalities. 3x is somewhere between 12 and 21. In fact, it's anything between 12 and 21 is what 3x is. Now what we want to do here is simplify this, solve it, so that we've just got x. Same signs, but just x. Now how did I do that on my last equations? How did I go from 3x to just being x? Yes, for those that said it, we divide by 3. Divide by that number touching the letter. Now, we've divided the middle by 3, and that just gets us 1x. 21 we divide by 3, and we get 7. And 12 we divide by 3 to get 4. You divide every section of our inequality. There's 3 sections there, one there, one in the middle, yes Murphy, and one over on the right hand side. 3 sections there, and you divide all of them by 3, you know. So before we said what you do to one side you must do to the other. Now we say what you do to one bit of the inequality you must do to every bit of the inequality. So x is between 4 and 7. On a number line I'd need both of those numbers, so 4 and 7. I don't need any others. There's no equals there, so it's just an open circle and join it with a line. Yep, so x is bigger than 4 but less than 7. Let's try that again. I'll show you what I mean again. Okay, this time x is less than 8. And when I do that, I get a number that's either bigger than or equal to 2 or less than 6. So if I was doing this normally, I'd just add 8. And that's exactly what I'm going to do here. Add 8 to all 3 sections. Because then that leaves x on its own. Now 6 plus 8 is 14. 2 plus 8 is 10. So x is bigger than or equal to 10, but less than 14. On my number line, I put in the 2 numbers, the 2 sort of boundaries, if you like. And it's a filled-in circle on 10 and an open circle on 14, because there's no equals on the 14. And then join them with a dead straight line using your ruler. Okay? I'm just going to make sure that looks a bit confusing there, doesn't it? So I'm just going to make sure that does look like an open circle. Do that again. So an open circle on 14 because there's no equals sign. Okay, just try those. Now remember, what you do to one section of the inequality, you must do to all 3 sections. All right, so pause the video, unpause when you're done, and put them on a number line, please. We've unpaused. Okay, 5x. So what I want to do is divide that by 5 to just have x. But of course, what I do to one part of the inequality, I must do to all parts of the inequality. How exciting, yes? So 10 divided by 5 is 2, or 2 if you are French. And 45 divided by 5 is 9, which is a different word in German, but I don't know German, so I can't tell you. Let's go 2. So my 2 boundaries are 2 and 9. X is bigger than 2. There's no equals, so I put an open circle. it's less than or equal to 9. That means I need the filled in circle because there's equals as well. Join it with a line. I hope this is all coming back to you now. All coming back to me. Who sung that? Whilst I'm thinking of that, who sang that? It's really annoying. Anyway, take away 6 to get x on its own, because 6 take away 6 is nothing. But what you do to one part, you must do to every part. Was it Celine Dion? 2 take away 6 is -4. 9 take away 6 is 3. So x is bigger than or equal to -4, so that's my bottom boundary. And x is less than or equal to 3, which was my upper boundary. So then I need a filled in circle on the equals down there and a filled in circle on there because the equals are there on both, and join it with a line. Yeah? Getting the idea? No? Well, go back and watch that again. If it's yes, woohoo! Let's move on and try and do a few more. So there's 6 for you to have a go at. Two-sided inequalities. What you do to one part, you must do to every part. Okay, pause and unpause. But you know the drill by now. What's that? You've unpaused? Brilliant. Okay, well, let's start speeding up a bit then. Right, take away 4 from every section. So 1 take away 4 is -3. Use the signs that are there. 13 take away 4 is, of course, 9. So on my number line, I need -3. I need 9. You might want to put 0 in there. Doesn't matter. On the lower end, it's an open circle because there's no equals. The upper end is a filled-in circle because there is an equals. Join it with a line. This one, take away 1 from every section. So we have -1 on the left, x on its own in the middle, and 8 take away 1, which is 7 on the right. So my two boundaries are -1 and 7, and put in the 0. Now both of these need to be filled in circles on the -1 and the 7. They're my two boundaries. And then a straight line, sorry, joining those two. Oh dear. X take away 13, add 13 to both sides. It's a lot in it. Now, -10 plus 13 gets us back up to +3. 13 take away 13 just leaves x on its own. 2 plus 13 is 15. So x is between 3 and 15. Both of those are going to be filled in circles because there's an equals on both. So x is bigger than or equal to 3, but less than or equal to 15 between those two numbers. This one, 3x, so we divide by 3 because we don't want 3 of them, we only want 1. But do it to all the sections. -6 divided by 3 is -2. 3 divided by 3 just leaves 1x on its own. 12 divided by 3 is 4. So there's your inequality. And the bottom boundary is -2. The top boundary is 4. You need open circles because there's no equals and a straight line between them. Right, x divided by 3. So what we can do here is times by 3. 2 times by 3 is 6. That cancels out the divide. So x is now just a whole x on its own. 5 times 3 is 15. And then copy those signs down. Remember, you don't need to think. Just literally copy the signs in. So x is bigger than or equal to 6, but less than or equal to 15. So we need filled in circles for my two boundaries of 6 and 15. I draw a straight line between. And on this one, 4x is greater than that. So let's divide by that number touching the letter. Divide by 4. So the bottom boundary will be -3. And the top boundary will be 5. So x is bigger than -3, but less than or equal to 5. So on my two boundaries this time, I need two different circles. You might want to, again, just put 0 roughly where you think it is. The bottom boundary is an open circle. The top one is filled in because there's an equals. Draw a line between. Okay. Now, when you do a task later, you're going to have to do this on Dr. Frost. And remember, Dr. Frost, let's just remind ourselves, or at least if I've set you a task on Dr. Frost, you'll have to do that. it likes you to put the answer in a specific way, doesn't it? You have to put them as two separate inequalities. Now, the right-hand one is easy because you just copy it. X is less than or equal to 5, and you pull the sign down from a little drop-down list. So you put X, pull the drop-down sign in, and type in the number 5. Now, the left-hand part on this one, although it says -3, whatever, it wants you to start it with X. So you've got to make sure you got the right sign. Now, remember, we're trying to say that X is bigger than -3, so I need the sign that says bigger than -3. And that makes sense, right? It's going to be bigger than the small number, but smaller than the big one. Bigger than the small, smaller than the big. It's between the two boundaries. So just, really think when you're putting those answers into Dr. Frost or a similar website. Okay, last few examples. And then we will move on to some more questions. So up here we've got a two-part inequality here. So we need to deal with the number touching the letter last. This is a two-step equation, all right? So we're going to take away 4 from all 3 parts. 4 take away 4 is nothing, so 2x is on its own. 14 take away 4 is 10. 22 take away 4 is 18. Put the signs in. Yeah? But then we need to do a second step, don't we? Because we don't want 2x. We only want 1, so we divide by that number touching the letter. So 5 is less than x, which is less than 9. X is bigger than 5, but less than 9. Remember, if you were doing that on an inequality on Dr. Frost, you'd have x is bigger than 5, x is less than 9. Right, now where's my little number line? I knew it was going to just appear there, so I'm going to have to rewrite my working out. Let's just redraw some of that somewhere where it's not going to be in the way, because otherwise it's going to look a bit silly. Also gives me the chance to change back to blue as well. Right, first thing I'm going to do is take away 4, and you need to do it from all 3 sections. So you get 10 is less than 2x, which is less than 18. And then the next thing we did was divide by the 2 to get 5 is less than 2, which is less than 9. I've just divided all 3 bits by 2. Right, so on the number line, put your 2 boundaries and put in your circles. Now these are both open circles because there's no equals in those signs. Put a line between. Remember in Dr. Frost, x is bigger than 5, x is less than 9. This one, deal with the number touching the letter last again. So you need to add 5 to all 3 parts to get, let's find out where that number line is now. Down there, good. 1 plus 5 is 6. 3x, and then less than 18, okay? So divide them by 3, because we don't want 3x, we just want x. Remember, whatever you do to one part, you need to do to all parts, so which is why we're going to divide that by 3. And we're also going to divide the 18 by 3 to get 6. So x is bigger than or equal to 2. X is less than 6. So when you're doing your Dr. Frost answer or similar, x is bigger than or equal to 2. X is less than 6. Yeah, if you're confused with that, you need to see me or whoever your teacher is. Now, filled in circle on the bottom boundary because it's got an equals, but the top one doesn't. It's only less than 6. So no filled in circle there. Draw a line between. Right, come on, we're nearly there now. Nearly there. 2 for you to do. Please do number lines as well. Then we'll do a few more. And then we can go do some practice and we're done. Pause the video now. Unpause now. Although it's a bit silly saying that because to hear it, you'd have to unpause. There's my number lines. Okay, come on, let's speed up a bit. What am I trying to say? It's a 2. I said 2-part inequality. It's a 3-part inequality. It's 2-sided, but it's a 2-step equation. That's what I was trying to say. I knew there's a 2 there somewhere. Right, take away 2 from all 3 parts to get 6x on its own, because they cancel out. 26 to take away 2 is 24. 44 take away 2 is 42. Just copy the signs down. And then, how are we going to get from 6x to x? Well, we divide by that number. Divide by 6. So x is bigger than 4. less than or equal to 7. So there's my two boundaries, 4 and 7. Open circle on 4. Filled in circle on 7 because it's equal to as well. Draw a line between. On this one, first of all, add 3 to all three parts. 7 plus 3 is 10. Copy the sign. 5x is on its own. 42 plus 3 is 45. And then I don't want 5x, I only want 1. Copy the signs down. So divide by 5. And you're going to divide by 5 on all three bits. 10 divided by 5 is 2. 5x divided by 5 is just x. Yes, Murphy. 45 divided by 5 is 9. So there's your two boundaries, 2 and 9. Filled in circle on both because there's an equals on both parts of the inequality. X is bigger than or equal to 2. X is less than 9. Remember, if you're doing this on Dr. Frost or similar, x is bigger than or equal to 2. Make sure you get your sign the right way round. X is less than or equal to 9. Bigger than the small number, smaller than the big one. Right, these are the last examples before you should be going off on your own to do some work. Okay, make sure you write down the question you're working out and the answer and draw a little number line, please. Pause the video now. You have unpaused and I've put some number lines in. Right, first thing you can do is take away 4 from all the parts. So 6 is less than 3x, which is less than or equal to, that's going to be 27. And the next step is divide by 3 to get 2 is less than x, which is less than or equal to 9, because 27 divided by 3 is 9. So two boundaries, so 2, 9, open circle on 2, filled in circle on 9, because there's an equals. Draw a line. Right, here, take away 1 from all three parts. 1 take away 1 is nothing. Copy those signs down. 57 take away 1 is 56. Oh, why did I do this? I've got to know how many 7's going to 56. And it is 8 of them. Right, so we're going to divide by 7. 0 divided by 7 is still 0. 7x divided by 7 is x. 56 divided by 7 is 8. So there's my two boundaries, 0 and 8. I need a filled in circle on both. Straight line between them. Okay, add 10 to all three parts. In fact, I can't put that in there because I won't have enough space. I'm a little bit cramped down here on this page, trying to get these questions in. So we're going to add 10 to get 12 is less than or equal to 4x, which is less than or equal to 24. We then divide by that number touching the letter. Divide by the 4 to get 3 is less than or equal to x, which is less than or equal to 6. Two boundaries, 3 and 6, both with filled in circles. Draw a line between. X is bigger than or equal to 3. X is less than or equal to 6. Bigger than the small number, smaller than the big one. Does make it sound like some kind of game show. Right, add 9 to all three parts. 17 plus 9 gets closer to 0, doesn't it? So that will be negative 8, which is less than 4x, which is less than, I'm adding 9 to that, 20. And then divide by that number touching the letter. Divide by 4. So negative 2, because minus 8 divided by 4 is minus 2. 4x divided by 4 is x, which is less than 5. X is bigger than minus 2, but smaller than 5. So let's put our numbers in. Because 0 is in the middle of here, I'm going to put 0 in as well. But the two boundaries are minus 2 and 5, and they're both open circles. Straight line between them. Let's really speed it up. Okay, add 12 to all three parts. No, don't know. It says speeding up and he writes in the wrong place. So let's add 12. Let's get rid of the 12. Oops, that is a 2, apparently. To all three bits. Minus 21 plus 12 is negative 9, which is less than or equal to 3x, because I got rid of the 12. And then 3 plus 12 is 15. And then divide by that number, touching the letter. Divide by 3. So minus 3 is less than or equal to x, which is less than or equal to 5. So there's my two boundaries, minus 3 and 5. 0's in there, so let's put that in as well. And these are both filled in circles with a line between them. Last one. Well, we're nearly there. Take away 4 from it. Do you know, every time I start it by putting it there and I haven't got space. Let's take that off again. So I'm going to take away 4 from all three parts to get 25 is less than 5x, which is less than or equal to 100, and divide by that number touching the letter, which is 5. 25 divided by 5 is 5, which is less than x, which is less than or equal to not 200, 20. There's my two boundaries then, 5 and 20. This is the wonder of an empty number line. There's no scale, so you make up your scale. Putting the numbers on you want. Right, open circle on 5, close circle on 20 because it's got an equals. Put a line between them. X is bigger than 5. X is less than or equal to 20. Now you can go and do a bit of practice. Now remember, on that last one, for example, where it said 5 is less than x, which is less than 20. So when you're putting your number in the number on Dr. Frost with this one, if you're doing this worksheet, remember it's bigger than the small number. That's x is bigger than 5. Look, that's what it says. X is bigger than 5. So write that. Remember, you just select that from a drop-down list, the little sign. And the other one, x is less than or equal to 20. The top boundary is easier because you just write it as it's written. X is bigger than 5, but less than or equal to 20. Okay. It says pause, but actually the video will stop now. Off to Dr. Frost if I've set it for you. Farewell, good luck, and bye-bye.